5-6, add expressions, number 14. On a math test, Sarah has to identify all the coefficients and constants of the expression 4 plus n plus 7m. Sarah identifies the only coefficient as 7 and the only constant as 4. Identify all the coefficients of the expression. So on this one, we want to remember that coefficients come in front of variables. So we have a variable right here, and we have a variable right here. Variables are the letters that we have. So when we look at the coefficients for m, the coefficient is 7. Don't write equals here because m does not equal 7. It's just that the coefficient for m is 7. N does not have anything written in front of it, but remember there is a little invisible 1 there. And so Sarah's mistake was she did not consider that there was a little invisible 1 in front of the n for the coefficients. Identify all the constants. Well, we only have one constant, that's 4. A constant does not have a letter after it. What error did Sarah likely make? Sarah did not remember there is an invisible 1 in front of the n. Didn't. Sarah didn't remember that there is an invisible 1 in front of the n. Next page. Page 308, number 15. The width of a rectangle is 5x minus 2 5/10 feet, and the length is 2 5/10 x plus 8 feet. Find the perimeter of this rectangle. Now on this one, they're just wanting us to write the expression for the perimeter of the rectangle, so it is a little bit poorly worded here. But I'm a big fan of drawing the picture and writing the information that fits from the problem on the picture. So it's telling us the width. The width is generally the shorter distance, and it's telling us that that is 5x minus 2 5/10 feet. So width is equal to 5x minus 2 5/10 feet. That's our width. And the length is 2 5/10 x plus 8 feet. So I'm going to write that right in here, so I'll have room down here to write my final answer. So to find the perimeter, we add all the sides up. So the perimeter of this rectangle would be side plus side plus side plus side. So the perimeter is going to be, we have 2 widths. So I'm going to take 5x minus 2 5/10, and I'm going to multiply all of that by 2. because there's two widths. There's this one and that one. You could also represent this just as repeated addition. 5x minus 2 5/10 plus 5x minus 2 5/10. Then we're going to add the other sides. And again, there's two of them, exact same length. 2 5/10 x plus 8. And so now I'm going to use my distribution property, and I'm going to distribute the 2's throughout the parentheses. And I'm going to get 2 times 5x is 10x. And I'm going to change this to a negative, plus and a negative. 2 times 2 5/10, that's 5. And that's going to be a negative. So I've finished distributing this 2 to each of the terms inside the parentheses. Now I'm going to move over here. 2 times 2 5/10 x is going to give me 5x. And this is already positive. 2 times 8 is 16. So now I'm going to look at it and I'm going to combine my like terms. I can see that I have 10x's and I have 5x's. So I'm going to combine those and I'm going to make that 15x. And for my constants, I'm going to check those off. For my constants, I have a negative 5 and I have 16. So when I combine those together, I'm going to get 11. So this is the final perimeter equals 15x plus 11 feet. This is my final answer for that problem. Number 16. Nina has X coins. Clayton has 5 fewer coins than 6 times the number of coins Nina has. Write an expression for the total number of coins Nina and Clayton have all together. Simplify the expression. So in this problem again, we have those words, fewer coins than. So we need to remember that whatever precedes that phrase means that we are going to do this operation with this number after whatever comes after those words. So let's get this organized. Nina has X number of coins. We don't know what her number is. But whatever Clayton has, he has 5 fewer coins than 6 times whatever Nina has. So first we're going to look at what Nina has, and we're going to multiply it by 6. She has X, so we're going to take 6X, 6 times that. Now we're going to go back and look and see what we do with the 5. He has 5 fewer coins than 6 times Nina's coins. So now we're going to subtract the 5. Write an expression for the total number of coins Nina and Clayton have all together. So we're going to be combining these two quantities, and then we're going to simplify the expression. So Nina has, I'm going to put a little line here, Nina has X, and when we add Clayton's amount, this would be the expression. So I'm going to change this to plus a negative. And we need to simplify the expression. So we're going to combine like terms. So we're going to combine the 6x and the 1x. And we're going to get 7x. And then we don't have any other constants. So it's just plus negative 5. Number 17. Use the expression parentheses 8x plus 2 close parentheses plus parentheses negative 9x plus 7 close parentheses. Find the sum. So I'm going to rewrite this and group things that are the same together. Because I have all addition for my operations, addition is commutative, I can rearrange these. So I'm going to start with my x's, and I'm going to have 8x and negative 9x. So I've taken care of my x's. Now I'm going to take care of my constants, 2 plus 7. And I'm going to put grouping symbols around them, not necessarily because they have to be done first, just to remind myself that these are the things that are the same and these are the things that are the same. So 8x and negative 9x is going to give me negative 1x. And again, you don't have to write the 1 in there. Plus whatever this quantity is. 2 plus 7 is 9. Explain how you know when to combine terms with variables. So terms that have the same variable or variables can be combined. We haven't talked about this yet, but sometimes you're going to have terms that instead of just having one variable, have two variables. And that's why or variables is written in there. For example, we could have 8xy plus 10xy. And as long as the variables are exactly the same, it actually doesn't matter the order. This is the same as 8xy plus 10yx, but you're hardly ever going to see this written that way because these are just multiplication problems. 8 times x times y plus 10 times y times x. So that's the reason the order doesn't matter. This could actually be y 10x, but you never see it written that way. So that's why I included the word or variables here, because later in algebra, you're going to have terms wherein after the coefficient, you're going to have more than one variable. Number 18, this is all about Gabe. Gabe goes to the mall. He bought K model planes. So that means he brought some number of model planes. We don't know how many he bought. And he spent $24 on books. Then he spent another $25 at the store. Write an expression that represents the amount Gabe spent at the mall. Well, over here in the picture, we need to look at this because it's giving us some information. Each model plane costs $14.99. So he bought some model planes. We don't know if he bought 1 or 2 or 3 or 4, but however many model planes he bought, you would take that number and multiply it by $14.99. So instead of trying to guess how many model planes Gabe bought, we're going to take that number and let the variable K represent it. So we're going to have K, which is the number of model planes he bought, times $14.99. And so typically we write the coefficient first. So 14 and 99/100ths K represents whatever he's going to spend on the model planes. Then it says he spent $24 on books, and he spends another $25 at another store. So if we're going to simplify this expression, we would combine our constants. So that would be 14 and 99/100ths K plus 24 plus 25 is 49. Doesn't tell us we have to simplify it, but it's good practice, math practice. How much did Gabe spend in all if he bought 3 modeled planes? Okay, so we take our expression and we substitute in 3 for K and then add the $49 to that. So because they want to know the total, we can put the equal sign there. We're looking for an equation. And so $14.99 times 3 gives us $44.97. And then we're going to add the 49. So Gabe spent $93.97. Okay, last problem. Assessment. A middle school with X students, some number of students, ran a survey to determine the students' favorite activities. The table indicates the number of students who enjoyed each activity. Write an expression in the table for each activity to represent the number of students who enjoy the activity most. So the activities are dance, soccer, and baseball. And the word description is 25 more than 1/10 of the students. And remember, they're going to represent the students in this problem with X. So I'm just going to write X right here. So every time I see students, I know that I'm in my expression, I'm going to be putting the letter X. Now remember, more than means that whatever the number is that's in front of those words is going to come after whatever is happening after it. So we need to write an expression that shows 1/10 of the students, or 1/10 of X. So we can choose to use a fraction or a decimal. So I'm going to write it both ways. First, I'm going to write it with a fraction. That's 1/10 X. You can put your X down there by the 10. You can put your X right in the middle of the two of them. You can actually put it right up here. That would work as well. Most common is right kind of in the middle. That just means 1/10 times X. So 1/10 of the students. The word of in math means do this operation, multiply. Now 25 more than. So I'm going to add 25. If I used a decimal, I would have 0 and 1/10 X plus 25. 20 fewer than 3/10 of the students like soccer. Fewer than. Fewer means subtract, but I'm not going to do that until I write this part of the expression out. So this is 3/10 of the students. So 3/10 X, and then it says fewer than, so I'm going to be subtracting, and 20. So again, if I prefer decimals, this would be 0 and 3/10 X minus 20. And baseball, 21 more than 1/10 of the students. So 1/10 of the students, again, 1/10 x, more than means add, and I'm going to be adding 21. So 0 and 1/10 plus 21. Write a simplified expression to represent students whose favorite activity is either dance or baseball. A simplified expression. So what we're going to do is we're going to focus on the dance and the baseball. And we're going to be combining those. So I'll go ahead and use the decimal format, but you could use either format. So here are my dance people. I'm just going to put those in parentheses to show that they're one group. And then my baseball people are over here. Oh, I forgot my X right there. And then it says write a simplified expression. So that means I'm going to combine like terms. So I'm going to take everything that has an X and put it together. And again, these are just for grouping purposes. And then I'm going to take 2 plus 21. And I'm going to get, 25 plus 21. And I'm going to get 46. So this is the simplified expression. Two tenths x plus 46.